This is section 6, derivative rules, example 4. So in this example, we're talking about the sum or difference rule. And all it means is that when you add functions or subtract functions, you just take the derivative of each individual term, one at a time. And that's it. And then you use whatever sign is there. So for example, in A, we have x squared plus 5x minus 3. Well, the derivative of x squared is taking the 2, moving it to the front. So y prime equals 2x. The derivative of 5x is 5, because remember, all that happens is that x goes away. And the derivative of a constant 0. So that's all you have to do. Okay, just take each term piece by piece. Now there will be times where you have to rewrite things and simplify things first and then take the derivative, but we'll get to those types of problems. For b, f prime of x. For the x to the fourth, we take that, move it to the front, so we get 3x cubed. We take this 3, move that to the front, so we get negative 9 halves x squared. Move the 2 to the front, so we get plus 4x, and the derivative of x is 1. The derivative of negative 6 is 0. For part C, we cannot leave it like this. We don't know a rule yet for a function inside of another function. So for now, we're just going to have to take the 2x minus 3 and double distribute it. So when we do, we have 2x minus 3 times 2x minus 3. All right, and in case you forgot how to double distribute, here we go. We have 4x squared minus 6x plus 9. We combine like terms, so we get 4x squared minus 12x plus 9. So when you take the derivative, y prime, it's going to equal, well, that becomes 8x minus 12. Done. Now just like before, if there's an x in the denominator, you're going to have to move it to the numerator in order to use the power rule, because for now, power rule is the only thing we know how to do. So this ends up equaling 4x to the negative first power minus 4x to the negative second power plus 4x to the negative third power. We're taking our exponents and moving them to the front again. So we multiply, we get y prime equal to negative 4x to the negative second power plus, because negative times negative is positive, 8x to the negative third power minus 12x to the negative fourth power. For part E, we are going to distribute first. So let's go ahead and do that. Now, 6 times 2 is 12, and root x times root x is just x. 6 root x times negative 3 is negative 18 root x. And then I'm going to go back and change that square root of x to the 1/2, because we need our exponents to be rational. So f prime of x ends up equaling 12 minus 1/2 times 18 is 9, x to the negative 1/2. And that's the answer. For part F, this is going to take a little more work. So let's put this over here on the side. Now, the numerator we're going to have to double distribute, and then we'll divide everything by 2. So we have x squared minus x plus 1 times x squared minus x plus 1. All right, we have x to the fourth power minus x cubed plus x squared. We have negative x times x squared, so we have negative x cubed plus x squared minus x. Now we distribute the 1, which just gives us what's there, so we get x squared minus x plus 1. We combine like terms, so we get x to the fourth minus 2x cubed plus 3x squared minus 2x plus 1. All right, now I have to divide all of that by 2. So, by dividing by 2, you're really secretly just multiplying by 1/2. So I'm going to write that over here. All right, so y ends up equaling 1/2 x to the fourth power minus half of 2 is just 1, so x cubed plus 3 halves x squared. Running out of space. Let's see. Minus x plus 1/2. That's what we're taking the derivative of. So y prime means moving the 4 to the front. 4 times 1/2 is 2. So we have 2x cubed minus 3x squared. 2 times 3 halves is 3. So plus x minus 1. That's the answer. All right, G. Whew, this one's a little bit easier. Right? We just have to take that root x and the cube root of x and move them to the top and make them rational exponents. So we get 8x to the negative 1/2 minus 6x to the negative 1/3. Remember, the negative makes it move to the top, and the root is the rational exponent. Now we take the derivative. So negative 1/2 times 8 is negative 4. We subtract 1 from negative 1/2, which is negative 3 halves. Negative 1/3 times 6 is negative 2. Positive 2, because 6 divided by 3 is 2. And then negative 1/3 minus 1 is negative 4/3. And that's the answer. For H, if you notice, there's just an x in the denominator, and we don't have a rule yet. We will, but we don't have one yet for where you have division. So what we're going to do instead is split up our fraction. We're going to have 9x over x minus 3 root x over x, which means that these x's cancel, so we just get 9. And then for the root x, remember that's just 1/2. So 1/2 minus 1 ends up being x to the negative 1/2. Oh, with that 3. Right, that 3 didn't disappear. So y prime, well, the derivative of 9 is 0. So we really just have to worry about this negative 1/2 multiplying by negative 3 to get 3 halves x, and then negative 1/2 minus 1 is negative 3 halves. Almost done. I. For I, we're going to factor first. Okay, and the reason I'm going to do this is because you can't just separate them. It's not possible, at least with our knowledge right now, because 2x plus 4 has addition in the denominator. So we're going to separate this so that the numerator is x minus 8, x plus 2, over 2 times x plus 2, right? Because 2x and 4 both have 2's in them. So that goes away, and we end up with x minus 8 over 2. That can be separated. We can rewrite that as 1/2 x minus 8 over 2, which is 4. So now when we take the derivative of that, y prime is just the derivative of 1/2 because the derivative of a constant is 0. So the answer is 1/2.